U-A-M-P. That is incorrect.
A door is ajar.
How did all those talking toys of the 80s work?
What's the difference between men and boys? It's the prices of the toys.
And how can we make an Arduino tell unfunny jokes with nothing but a speaker connected? And what has one to do with the other? Find out in this video. Stick around. Those days, memory and computing power are expensive, so there was a need for a way to save memory when encoding voice. Linear predictive coding, or LPC, was the way to go. It's still used a lot for speech recognition and synthesis, but it's being replaced by AI more and more. But how does it actually work? Well, LPC emulates the human vocal tract. You can roughly model this as a buzzer that buzzes into a tube. Depending on its diameter and length, some parts of the buzzer spectrum get emphasized and others damped. In the real world, the buzzer is the larynx and the tube is mainly formed by the pharynx and the oral nasal cavities. Each of these has its specific resonance frequencies, the formants. So the idea behind LPC is to send a rectangle wave through a cascade of digital filters to approximate them. In 1978, Texas Instruments brought the TMS-5100 voice synthesis processor to the market. This and its successors were built into the Speak and Spell and other talking devices in the following years. The TMS-5000 series VSP chips have an oscillator whose frequency can be set with 6 code bits and its amplitude with 4 bits. This feeds into a chain of 10 digital filters that can be set by filter parameters that occupy between 3 and 5 bits. Including the repeat bit, each waveform is represented by up to 50 bits. Voiced frames as used for vocals need all of these, while unvoiced frames need 29 bits. The vocal tract changes its shape relatively slowly, so the filter coefficients can often be repeated. This is indicated by a repeat frame of 11 bits length. Silence has only 4 bits. With this, an average LPC frame has 30 bits. On the Speak and Spell, the LPC frames were stored in 2 stereo ROMs with 128 kilobits each. One of those could hold up to 2 minutes of speech. And here's the voice synthesizer TMS-5100 labeled as TMC0281, and of course the microcontroller that controls it all. But nowadays we don't need to mess with all those chips anymore if we wanna try LPC. Instead, there is an Arduino library available that emulates the circuit that we've just seen. Let's try this now. First I connect the speaker to pin 3 and 11 of an Arduino. This does work, but it is rather quiet. If you want to use an audio amplifier, you can use a little filter circuit shown on the GitHub page. Here I've connected it to a USB sound adapter so I can better record it for the video. If you are looking for an easy way to assemble your electronic circuits, PCBWay might be the right partner for you. With the KiCad plugin, you can simply upload your Gerber files to the website, specify your requirements, and a few days later, the boards will arrive. I love their high quality PCBs, and that's why I love to work with PCBWay. Soldering is always fun and done in no time, even for beginners. And PCBWay not only makes PCBs, they do also offer CNC machining, sheet metal works, 3D printing, and injection molding. Get everything you need for your awesome projects from one hand, so give them a try. The Talkie library can be easily installed with the Arduino Library Manager, and it comes with numerous ready-to-use examples that run right out of the box.
.07 meter, .04 meter, .03 meter.
Using it is actually simple. Just include the library header file and one of the vocabulary headers. The USTI-99H vocabulary file is a good starting point. The corresponding C++ source file contains the LPC parameters. This data was pulled from the TI-99 speech synthesizer module for the Texas Instruments TI-99-4A. It has about 350 of the most commonly used US English words. Additionally, there is a US large header file that refers to words from demo ROMs for the TMS-5220. These are about electronic and measurements,
caution, 1000 volts,
time and weather,
Time is 10 past 10 a.m. Rain.
and avionics.
November Oscar Papa ready for departure.
Back to coding. You first need to get an instance of the Talkie class. Then call its say method with one of the byte arrays from the header file as a parameter. To let it say whole sentences, you can simply call the say method successively.
Hello, I am the computer.
If you include the Talkie utils header file, you get additional useful functions like say QNumber that can read 32-bit long values, or the function say QFloat for floating point values.
3 is less than 3.1415.
And if you are missing some words in the supplied header files, you can also create your own with your own voice and in any language. One of the videos linked on the GitHub page shows how to make an RPC array with an app named BlueWizard. However, this does only run on macOS. Luckily, there's a Python port of this that can run on all operating systems with Python installed. I'll be showing this one instead. So here is its user interface. What we need to do as a first step is to create the WAV file. I'm using Audacity to record one. There we go. Hit the like button and subscribe to never miss any of my videos. Now I trim the silence at the beginning and at the end. We can optimize the recording if we go to Effect, Volume and Compression, and then Compressor. This enables a better utilization of the dynamic range. Now I go to File, Export Audio, Export to the computer. Optionally, give it a meaningful name. Format is WAV, Mono, sample rate 8000 Hz, encoding is unsigned 8-bit PCM. Signed 16-bit instead will give the exact same result. Back to the Python wizard. There I open the WAV file that I've just created. I also change the output format to Arduino. So the byte array gets the right format to be used in an Arduino sketch or in its header file. Also the table variant needs to be changed to TMS5220. We can now select it all with Ctrl A and copy it to the clipboard with Ctrl C. Then paste it into an Arduino sketch with Ctrl V. See how simple that is.
Hit the like button and subscribe to never miss any of my videos.
Have you noticed the hisses between the words?
Subscribe to never miss any of my videos.
We can get rid of these if we set the Envoy threshold value to 0.9. There are more values to play with, but for me, changing them did not really improve anything. So I leave them as they are. The program needs a few seconds to recalculate the parameters, but after updating the Arduino sketch with these, the hisses are gone.
Hit the like button and subscribe to never miss any of my videos.
Now I'm gonna show you a library that can play WAV files directly. Open the WAV file in a hex editor like HXD. Then export it as a C file. Copy and paste the array from there into the Arduino sketch. Program prevents the Arduino from copying the array into the SRAM, which would lead to an out-of-memory error. And Progman requires the array to be immutable, which is achieved by the const qualifier. Here's the result.
Hit the like button and subscribe to never miss any of my videos.
Sounds like an old watering can, but still better than what we've heard before. And compared by the memory usage, it needs around 30 times more of the Arduino's program memory. So there's not much left for the program itself. Now let's compare the spectrograms. The upper is from the original WAV file, below is a synthesized spectrum. The horizontal lines are the formants. They look quite similar, don't they?
A door is ajar. Don't forget your keys. Your headlights are on. Thank you.